Okay, so this is capacitance. A capacitor essentially is just two parallel plates. That are sitting on top of each other. Okay, yeah, in between them there's an electric field. Now these parallel plates, to create this electric field, must have an unbalanced charge. So top must have too many electrons, and the bottom must have too few, so it's positive. Oh, wrong way around, sorry. Looking at the arrows on the electric field. Now, how does it actually work? Okay, let's say we had a circuit here connected like this. Actually, we might just put in a switch. Now when we close the switch, there's a build-up of electrons here. And what's going to happen is those electrons want to balance out, so there's going to be a small current for a little while when the switch is closed, where electrons are going to then build up on this, and this whole side of the circuit will become negatively charged. Because of that, this side here will repel electrons, so electrons will move away from here to balance up, but this side here will be left positively charged. Okay, now this current only goes for a little while the charges find their new balance point. Now, just clear some of this off. What that means is you now have a electric field between the two. Okay, if you then open the switch again, then there's no longer going to be a flow of electrons, but the electrons now actually can't get back out. Okay, so they are now stuck there. And you now have a situation where there is too many electrons stuck on here, too few on there, so you have a positive plate and a negative plate. Okay, and they stay there, it doesn't leave. So now what you've done is you've created a source of potential energy. There's a build-up of charge, and they want to get balanced again, but at the moment, because there's no circuit, they cannot get balanced. So if we then actually maybe connect up another circuit here with a light bulb and a switch, and if we close that switch, then the electrons are going to flow out of here, around here, to try and balance up the circuit. And that means you must have a current, and that means you can get some light for a little while until it's balanced. So what are some uses of capacitors? Capacitors are used to store electrical charge, and hence also to store energy. So examples of this, you could use it as a battery source. You could use it for like camera flash and so on. You could use it in stereos to prevent clipping. Could be used for timing circuits, in other words turbo timer, light timer, things like that. Because the capacitor essentially is just two metal plates parallel to each other, this is what this is. You can see there's metal plates, and then there's something called dielectric, which is just like a plastic put in between the plates and then wrapped up. Okay, so that's all it is. It's just, you don't need to have just two plates, you can have as many plates as you like. Okay, so what does capacitance mean? What it means is, say you had a room, 2 rooms, and you had someone pushing charges into this room. Now each of these pushes is the voltage, okay? And each one is the same size. So we're pushing these charges into the room of a certain voltage, and because one room is larger, it has greater scope for collecting charges for that size of push than a little room. So this one has a larger capacitance, while this one here is a smaller capacitance. So, because of that, if we have 2 parallel plates, okay, the capacitance of the capacitor is how much charge you can store per volt, okay, and so the unit for that is the farad. And these are symbols. So for example, a capacitor of capacitance 4.7 microfarads is charged fully by connecting to a 12 volt DC supply. Calculate the charge stored in the plates of the capacitor. Okay, so we're just using this formula here, C equals Q over V. Q equals CV. So 4.7 times 10 to the minus 6 multiplied by 12, and you get your answer.